Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We're given three 2x2 matrices A, B, and C, and we want to find each inverse, carefully checking invertibility along the way. This is our main tool. Compute the determinant AD minus BC. If it's non-zero, the inverse exists and is found by swapping A and D, negating B and C, then dividing by the determinant. Determinant 0 means the transformation squashes the plane into a lower dimension, so it can't be reversed. Visually, a 2x2 matrix sends the unit square to a parallelogram. The absolute value of the determinant is the area scale factor. If the area becomes 0, the shape collapses and there's no way back. For A, the determinant is -12, definitely non-zero, so A is invertible. Great, now we apply the formula. Swap the diagonal entries, they're both 0 here, and negate the off-diagonals. Then divide everything by -12. Simplifying entry by entry gives a clean inverse with fractions 1/4 and 1/3. This matches the idea that A sends 10 to 04 and 01 to 30. For B, the determinant is 4, so it's invertible. Now the same inverse recipe. Swap the diagonal 2 and 2, no change, negate the off-diagonals, then divide by 4. After simplifying, we get a lower triangular inverse, nice and structured. For C, the determinant is 1. That's special. Dividing by 1 means the inverse will have integer entries. We still do the same pattern, just no scaling needed at the end. Swap 3 and 7, negate 4 and 5. Since the determinant is 1, we're done immediately. A fast confidence check is to multiply the matrix by its proposed inverse and see if you get the identity matrix. If your product equals this, your inverse is correct. Every time, it's the same rhythm. Determinant first, then swap negate, then divide. Here are the final results, all coming straight from the same 2x2 inverse formula. Keep the momentum going. Hit the next video, and let's unlock another powerful idea together.